All right, we're going to start with 13.3, which is gas stoichiometry today. And you have the notes that I have here in front of me. And so we're just going to start with these notes. So we're going to go through two example problems. So the first one just basically says a sample of nitrogen gas has a volume of 1.75 liters at STP. How many moles of N2 are present? Okay, so this section goes into stoichiometry. Stoichiometry, remember, is our mole map. So we are going back to that stuff. Now, there's a big part of this notes that we're going to look at, and it's right here. I'm just going to get a highlighter and come over here, and I'm going to highlight right here on our notes. Look at that. There you go. STP. STP is super important, because if this problem did not say STP, we could not use what I'm getting ready to show you. So STP allows for us to say that 1 mole equals 22.4 liters. So, and that's super important because that is an extension of our mole map. So now if we want to go from grams to liters, we could go from grams to moles, moles to liters. Or if we wanted to go to molecules to liters, we could. It's just an extension. It's another step. This problem specifically gives us 1.75. So I'm going to write that over here, 1.75 liters of N2, and it wants us to find moles. So this is a straight one-step conversion problem, because you're going to put your liters of N2 on bottom, what we're trying to get rid of, look, liters, liters, okay, and then you're going to put your moles on top, and then we're going to use that statement that we just showed right there up above, 1 mole, 22.4. So 1 goes with the mole, 22.4 with the liters. Alright, and then we do our math. So this is going to be a division problem where we take 1.75 divided by 22.4. So we do that. And then we do sig figs as well, right? They're giving us 3. So when we do our math, we get an answer with sig figs of 39.2 moles of N2. Just like that. And that would be our final answer. Okay, so it's just like our gram to moles conversions, one step. Easy enough, right? Now, of course, they get a little bit more complicated. The next example is giving us, talking about this stuff called quicklime. So if we read through the problem here real quickly, carbonate, CaO3, calculate the volume of CO2 produced at STP from the decomposition of 152 grams of CaCO3 according to the reaction CaCO3 yields to produce CaO plus CO2. So that's the problem that you have on your sheet. So we need this reaction right here. This one right here. This is the reaction we're going to focus on. Okay. And let me write it on the paper because I can see that the type version is a little blurry. So I'm just going to write CaCO3. And for some reason the handwritten copy is not as blurry as the typed version. So I'm just going to write it here on my paper so you can see that a little better. There you go. Alright, now what they gave us. In the problem they gave us 152 grams of CaCO3. They want us to find the number of liters of CO2. This is a problem just like a grams to grams problem. Instead of though going from grams to grams, we're going to go from grams to liters. So in fact, it's almost a little easier because we don't have to find 2 molar masses. We just have to find 1. So I'm going to start off 152 grams of CaCO3, and I'm going to change that from grams of CaCO3 CO3 to moles of CaCO3. Now how do I do that? Of course, the 1 goes with the mole, and then I have to find the molar mass of this CaCO3. So I come down here and I say CaCO3, CaCO113, 40.078, 12.011, 15.999. And so now that'd be 40.078. That would be 12.011. And this one would be 47.997, and then you have to add them all together, right, to get your total. So that's 100.086. All right, and that's the number that goes up here. So 100.086, and I didn't say anything, but down here we do have to do sig figs. So we look at the sig figs down here, and so they were 3 down there, so we have 3 after the decimal spot, and so we didn't have to worry about that. So now we have moles of CaCO3, but we don't want moles of CaCO3, so we're going to get rid of the moles of CaCO3 by starting a new fraction, putting moles of CaCO3 on bottom. And then we're going to put our moles of CO2 on top. And then make sure your reaction is balanced. We didn't do that, but this reaction is balanced. So, and notice that we have moles to moles. And we go back up to our original equation. It's a 1-to-1 since it's already balanced. And so we're going to put in our 1s. And so we now have moles of CO2, but we don't want moles of CO2. So now we're ready to go to the next step where we get rid of moles of CO2. So I'm going to do another fraction. I'm going to write moles of CO2 on the bottom. And then I'm going to write liters of CO2 on top. And then that's where I get to use that 1 mole is 22.4 liters, so 22.4 goes with the liters, 1 goes with the mole. And then of course now I'm ready to do my math. So I go back and I look and I say, okay, I have 152, and then I'm going to multiply that by my 22.4, and then I'll have to divide that by 100.086, and then I'll get an answer, and then I'll have to go back to the given, and the given is 3 sig figs. So my answer can only be 3 sig figs. So I'll calculate everything, put my answer in 3 sig figs, and so when I do all the math with the sig figs, I get 34.0 liters of CO2. And so that's my final answer. And so this should feel really familiar. It feels just like the stoichiometry we did in chapter 11. And so you guys are going to do some more practice and work on it on your own. So